Good morning, everyone. What I'm going to go over today is some more stack demystifying. Nothing too hard here, but we all have to start somewhere, and understanding how a stack works is really important if you want to get into binary exploitation, among other things, memory forensics, all kinds of good stuff. It's really, really important to learn assembly, and it's really important to learn some binary exploitation as we develop as hackers. So, what I'm going to do today is take you through another. Um, Let me just haul up my Linux. I'm going to take you through another um, stack demystified video. So, what we will do is take this small C program I wrote the other day. Basically, it has argument count, argument vector, int A, int B, character string. Lee was here lols, and this time I made the string bigger because I want to show you the difference between the last time we used fuck, which stores really nice in a 4 byte 4 byte word. Here we do stuff a little differently. We have to get in the load effective addresses and stuff like that. So little things that you need to know along the way, and after a while it all becomes second nature, I promise. So let me just jump into I'm in my binaries folder, so gdb/q to quiet the comments, and we're going to open up that file we just had a look at. Okay, so the first thing we do is disassemble a main function. And let me just walk through everything here in the main function first, and then we'll walk through it as we go through in GDB. So the first instruction here is push EBP. And as you can see, this AT&T syntax, which is what I prefer. You can do Intel syntax if that's your thing. I prefer this just because I'm a Linux head, and that's what I learned. It just makes more sense to me too. So first thing we do in stack creation is push the base pointer onto the stack. Okay, so that's all that's happening in that instruction. Next instruction, we're going to move the stack pointer to the same place as the base pointer. And I'll show you that's going to be in the top left-hand corner as we view our stack in GDB. And you'll get used to seeing this happen on every single program you open. So the next move, and this here is called the prologue. This down here, which closes the program, is called the epilogue. And you'll notice in some malware too, that'll be really messed up, and that's how you can tell that it is malware, just with edited prologues and epilogues. So let's get back to it. We're going to subtract hex 10 from ESP. So 16 base, that means we're going to subtract 16 bytes from the ESP. So ESP is going to be in the top corner, and then 16 bytes below is going to be the base pointer. And this here is the stack created. Now it's filled with gobbledygook. There's no actual information inside it. Sometimes though, once you get here and you're displaying, you'll look inside and there will be addresses and stuff. Don't get too wrapped around the axle about it. It's just filler. That's all it is. The next one, which we did not see in our first one, and why I wanted to cover this. Next, we're calling the PC, which is the program count. This in 86 is your EIP, your index pointer. So it's trying to figure out where we are in regards to everything else. And now this part here is where we are going to see it add this hex number to the EAX, which is the index pointer here. And this is where our string is going to be stored. Lee was here. As I said, it couldn't be stored in just a 4-byte memory. So this one's a little different. Next, we move down and we see X64 is going to be moved 4 bytes from EBP, which is our 100. Our 200 here, C8, is going to be moved 8 from EBP. And then we're going to load the effective address of this offset minus the EAX and load it into the EAX. And this is our message, Lee was here lols. And then we're going to load it 12 from the base pointer. Then the program closes out, and that's the end of the program. Fun stuff. So I'm going to put up a couple displays first. And I'm going to do three instructions of EIP. And this shows me Actually, let me just set a breakpoint and I'll get the instructions once I get inside. That's my mess up. So let's do breakpoint right here at the start, and I'm going to run it without any arguments. And here we are at the very first. As you can see, our 3EIP is here, and we get this neat little arrow showing us the next thing that's going to happen. So the next thing is going to happen with this program, it's going to push the base pointer onto the stack. I'm going to display 16 words in hex from ESP as well. And here's our stack. Here's the top hand corner. This is where the base pointer and the stack pointer are going to be pushed. So next we're going to push the base pointer here. And as you can see, this here is now zeroed out from what it was. That's where the base pointer is. So next move is going to be moving the stack pointer to the base pointer, and they're going to be at this exact same address right here. And I'll show you that. So let's hit next instruction. Let's print ESP. It's at 018, which is this right here, as you can see with this address. And now let's print EBP. And as you can see, same address as the base pointer. So our stack is not created yet. Our stack and our base pointer are pushed onto the stack now. And as you can see, the next instruction is subtract 10 hex from the ESP. So that's 16 bytes. So the base pointer will be down around here, and the stack pointer will be here, and there will be 4, 8, 12, 16 free bytes right there for our variables to fit in. So let's make the stack. If we print EBP now, we can see that it's at 018 right here. And now if we print ESP, it's subtracted up here to 008. And here is our full stack. So that is the stack created. That's the prologue of the program. And those happen every time you write a program. Here in assembly anyway. So the next instruction is a bit different than the last one I did, and this is the reason I wanted to do a bit of a longer string with Lee was here. I used fuck last time, and it fit really good into a 4-byte word. However, this here is much too big to fit in a word like that, so it gets stored a little differently. So here's our program count getting called, and this is the EIP. So next, it's going to add this hex number to the value we got from the PC right here. So this is going to add that value to the EAX register there. And that's all that one's doing. So now that that's done, we move into our move instructions, and these are going to move 0x64 and 0xc8, which is 100 and 200 in normal people numbers. and they're going to be moved 4 and 8 from the base pointer respectively. Okay, so let's go to our next instruction, and this is going to be moving 100 to 4 from the base pointer. So here's our base pointer. Here's 4 bytes here. So this here should have a 64 when we do this next instruction. And it's almost like I know what I'm talking about. There's the 64. So let's look at our next instruction. It's moving along 200 into 8 from the base pointer. That would put this address here. So we should see a C8 here in the next instruction. Perfect. And as you can see, the stack fills up this way. It goes to the bottom, first in, last out. So there it is. So now, as this one's a bit different than our fuck when from stack demystified, this one's load effective address, and it's minusing this hex from the value of PC that was loaded into EAX, and then it's moving that value into EAX. What's going to happen then, we're going to move that value in EAX into 12 from the base pointer. So that would be right here. So let's do next instruction. Now, our EAX has that value stored. Let's hit next instruction. And as you can see, this is our string address stored right here. So we can check that out. We can examine the words in hex of this place here. And as you can see, this looks like hex. So as you can see, LE IG. So as you can see at this place, we can only store so many, uh, variables. So what we can do, we can also go and place this here and then say, let's put in 10. And as you can see now, we can haul up something like hex to string converter from Rapid Tables. And we can have a look at these as well. So as you can see, it took more than one address to store Lee was here. So it just loaded the, so HERE. So this is Lee was here. And this is the last of the load effective address. So it goes to the start right here and it pushes out these addresses. Lee was here, and then we move into the epilogue, which is closing the program out. We move zero out EAX, we leave, and we rut. So next instruction, next instruction, next instruction, and continue, and we're out. So that is how things are loaded up onto the stack and how a little larger strings get stored. So if you enjoyed that, I hope you found it helpful, because this is the stuff you need to start mastering when you get into binary analysis. And it's a whole lot of fun, and it's not that hard. It's not so hard as what some people make it out to. So check that out. If you enjoy it, please share, and I'll get back to you guys later this week. Bye.